see over here, CDF we are going to represent as a capital of fx here, and the p property of random variable, which is property of variable here x less than or equal to x, so which is defined as the integration of pdf respected to x, which is from the negative infinity to x, which is, if we try to look at here, we have some notes. Okay, the notes here, the capital of fx here, which is defined as the area under the curve, which is equal to fx from negative infinity up to x, as indicated by the shaded region. This is some figure to show that we are gonna have from this box. Okay, so if you try to look at it, we are having area under the curve to represent the CDF here from the negative infinity, which is in this case is 0, which is until the x. So here you are. As for the second notes here, as you can see, f negative infinity, which is defined as 0, f infinity is equal to 1, which means the higher, which is not the higher, which is the highest value, the highest limit that you're going to have, it must be equal to 1 here. And number 3, which is, as I said before, for the continuous random variable, your inequality is not really important, which is property of x less than a, it will be equal to, property of x less than or equal to a, which is defined as the capital of fa here. So here you are, which is, as I told you, but you can put some notes here. I'm going to say it again, there inequality in continuous random variable is not important for continuous random variable. So you can see here, everything will be the same thing here. A will be equal to fb minus with the fa. So let's proceed. Example 7.16 here, already given some example, which is this example to represent how can you have from the PDF. This is a PDF, from the PDF to the CDF, which is where already given to the x between of 0 and 4, and the next question asks you to sketch of the y is equal to capital of fx, which is the one us sketch the graph of your continuous random variable for the CDF. And for C, we just want the x between of 2 and 3 only. So we can see for question A, we need to find the CDF. So if we try to look at here, we know we'll be having from the interval will be having from the 0 until 4, right? So we're gonna have start from 0. When the x less than 0, fx is equal to 0, because we're gonna start from 0, right? So we'll be having the function will be equal to 0. So we'll be having from 0 until 4, we'll be having integral for the fx here, pdf here, from the 0 until x. We are going to integrate from 0 until x, not 0 until 4, but it is 0 until x. Okay, please make sure for that one. Okay, so integrate from 0 until x, because why we are going to integrate from 0 until x? Because we want to have some function. As you can see, we'll be having x squared over 16 over here. And the next one, which is, since we'll be having from the 0 until 4, right? So x more than 4 you'll be having is equal to 1. So this is the CDF for the continuous random variable. So capital of fx, which is this is a piecewise function. As I told you, for the CDF, it will be start from the 0 and add up will be until the 1. And when the x less than 0, we'll be having 0, x between of 0 until 4. We are going to integrate from 0 until x, just now that we just discussed. So we will be having x squared over 16, and our last will be having 1 when the x more than 4. I hope you are clear about this part. Then the next one, question asking to sketch the graph. So if you try to look at the graph, when the 0, we will be going to have, when the x less than 0, so we'll be having 0 from the x until 4. So this is the x until 4, which is, you can put some notes here, which is this is a 4 here. So you'll be having what, which is x squared over 16. This is the curve, and this is the static graph. Here we'll be having 1 when the x more than 4 there. So then the next one, question C, we were asking to have property of x between of 2 and 3. So you can use the notes previously, which is you'll be having f3 minus f2. So you already have the CDF function x squared over 60, right? So just substitute when the f3 minus with the f2, which is 5 over 16. Or maybe you can put or here, which is you can integrate your PDF which is this one. Integrate PDF, which is 1 over 8x here, from where? From 2 until 3. Okay, let's proceed. Example 7.17. 7.17 here, I already have a solution curve. I'm just going to try to leave it for you first, which is try to understand it first. So if you have any problem, just do let me know so that we can discuss later. Okay, example 7.17, which is you can refer from the previous example. So let's proceed, which is the next one. We're going to see about the median. How can we find the median? Okay, so in other words, the median divides the area and the curve into half. So easy to see that. So if you want to find the median, this is the formula, which is we are going to integrate from a to m, which is m is represents our median. So you are going to integrate the PDF, so it must be equal with 0.5, which means capital of Fm must be equal to 0.5 here. So then the next one, okay, this is example 7.18, also a discussion, having a solution here. It is given a PDF, which is, this is our PDF, right, from the 1 till 3. We need to find the CDF. So to find the CDF, so we are going to have x less than 1. Why? Because the least limit, which is the smallest limit, will be 1 here. So x less than 1, which is fx, capital of fx will be equal to 0. So we're going to see from the x between of 2 and until 3, we are going to integrate from 1 until x. So please do remember about that one. And the last one, when the x is what? Is more than 3, we'll be having fx equal to 1 here. So this is your CDF. Okay, this is your CDF. Please make sure you are clear about this one. As question B, okay, we are going to focus for 7.18, which is how to find the median. So you may put some notes, 7.18 to find the median here. And you may practice to find the CDF, okay, which is your piecewise function of a CDF here. You may practice to do it. So as question B, to find the median, which is we know we'll be having the capital of Fm here will be the 0.5, is it right? So as we know, capital of Fm is equal to 0.5, which is capital of Fm, which is we'll be having this function, which is negative 1 over 8 x squared minus 8x plus 7. So just substitute x as m. It then equate with 0.5. So from here, solve your m. What is your m here? So m will be equal to 1.764 or 6.236. You have 2 answers, but you are going to choose only one answer. So which answer that you're going to choose? Only 1.764, because of what? We know that m must be in between of 1 and 3 only. It must be not greater than 3. So that's why our answer only 1 here. So I hope you are clear. As we are going to proceed with this next example, 7.19. You may refer from the previous example 7.18 and 7.17 just now. And the answer for the median for example 7.19 here, it will be equal to 3.4641. Try it first. Now we're going to see how can we have from the CDF to PDF. Maybe you can put some arrow here, which is what? From the CDF to PDF. So as we know, from the PDF to CDF, we are going to integrate, is it right? So it is a vice versa. CDF to PDF, we are going to differentiate, find the derivative. So 7.20 we already have a solution. So I'll just quick one. This is your CDF. Please make sure you can differentiate which one will be CDF, which one will be PDF. Okay, so this question asks you to find the PDF and sketch the function. So as you can see, for solution for A, they are differentiate. Okay, they are derivative. Okay, derive it. Okay, derive your which is derive 0, of course 0. Derive x cubed over 27, so you'll be having x over 9 here. Derive 1, of course you'll be having 0. So that's why the PDF will be having x over 9 for the x between of 0 and 3, and the last one for the PDF, of course 0. So you'll be going to have otherwise here. And this is the graph, which is 7.21. You may refer from the previous one. Okay, let's make sure you try it first. And 7.22. Okay, as for the example 7.22, already have a solution. It is a little bit tricky. Find the value of a and b. A, you can put it. You can see from these two functions. So just try to locate it first and find the PDF and calculate x between of 3 and 5. So try to look in the solution. Try to do it first. 7.23. I'm going to give the answer. The answer for A, which is C, will be equal to 1 over 12. Try it first. And question for C will be equal to 1 over 3. As for B, I'm going to give you later. Okay, let's proceed. The last one, expectation and variance of random variable. Okay, we do have it too in continuous random variable. So I'm going to have a quick one here. So for the expectation, we'll behave integral from negative infinity to infinity x, and then multiply with the fx respected to x. And then for the variance, we'll behave in the same formula as our discrete random variable. So let's proceed. 7.24. I already have a solution. Just try to do it first. And the next one, which is 7.25, I already have answers, but doesn't have a solution.